So we looked at the cup of hot water yesterday and put that ice inside of it, and we saw a couple different things. Explain one thing that we saw when we did that kind of mini experiment. Lauren?
Condensation.
Condensation. Where was there condensation? And condensation means going from what to what? Which phase to which phase? Yeah. From gas, so water vapor to a liquid. Where did we see that? On which cup?
Smaller.
Okay, on the smaller cup. So as the water vapor cooled down, right? We heated it up for it to become water vapor, but when it cooled down, then we saw it as little water droplets. What else do you see? Something else?
There is fog on the cup with the hot water.
Yeah, before we even messed with the small cup of ice, there was fog. Where did that come from? Yeah.
Like the mixture of the room temperature air with the hot water and the water vapor.
Yeah, so it was heating up that water vapor that was in the air, or possibly even creating some water vapor right there. And then finally, we saw some of that ice melt. I don't know if we talked about that a whole lot, but you know, a typical phase change that we've seen before, when energy transferred to the ice, that ice melted, went from something solid to something liquid. Okay. So with that in mind, I want to talk to you about one other thing, and I think somebody mentioned in here yesterday. Could we jump straight from a solid to a gas, or from a gas to a solid, and skip the liquid phase? And we can. In fact, I was going to show this to you. It's a type of frost that you're probably pretty familiar with. I had some this morning. I thought, oh, that's the video I'm going to show you. It's called hoar frost, H-O-A-R. And this is the kind of stuff that if it gets cold enough, kind of looks like this. Try to blow that up a little bit.
Oh, spikes.
This happened to me this morning. I parked my car outside.
Oh, that's unfortunate.
It was dry. There wasn't any rain, so it wasn't like turning a liquid into a solid. We saw a little condensation. So this is similar to what we did yesterday. You guys see that in the back? Trying to light up. I was going to get it with it. So they're adding sodium chloride like we did to cool the ice down even more. It takes a little bit of time for things to adjust. Less than 5 minutes though. Okay, and where'd that come from? It didn't change into something that was condensation in a liquid form. It just went straight from the gas around it to a solid form. So when we make that jump, we kind of skip the liquid phase. There's still a phase change there. That can happen. There you go. That answers your question from yesterday. All right, you can turn the lights back on. Next up, we've really come to the end of this investigation and kind of a group of investigations. So the thing that I'm going to have you do today is really take a look at this part. And I'm going to give you and your partner this sheet to try to fill in the blanks of some of this. So if you're watching at home, you can pause the video and see if you can figure it out. I'm going to give everybody one of these. And I'm going to give you the opportunity to work with a partner. And I'm going to say 3 minutes on the clock. And by that point, we should be done and ready to see if we got them all. 3 minutes, maybe even 2 minutes. 3 minutes is probably too much. Makes sense?
How would that be called?
What?
Like, what the gas?
Oh, there's a name for it. Let me take a look. All right, clock starts now. Ready, set, go. You can find a partner if you'd like, but fill in the blank for those answers. Sublimation. Sublimation.
You're supposed to put the G there. Oh, no, maybe they just didn't put a letter in gas, G in gas, and that's why they don't use it. That's what I'm thinking, but who does that?
What are you talking about? Nope. Now, blank as blank blank. Yep.
Water vapor. Water vapor. No. Well, we know. Something transfers the particle from the particles to the kinetic energy transfers from the particles to the ice cup.
Alright, I was gonna call it quits, but it looks like we need some more time, we got a little extra time.
As energy travels from
Done.
kinetic energy, those particles.
You're so proud, aren't you?
Nah, I thought I wasn't gonna be first. Cause I was basically just fellow versus everyone.
So if you wanna go around and help those that may need some extra.
Alright, so, this one? What happens to kinetic energy or the water particles if it goes away from the water particles? Does the amount increase or decrease? So, put what you think would happen.
The kinetic, yeah,
If the energy goes
kinetic
away.
energy of those particles, they, they start, no, kinetic energy of those particles,
So,
they had a word for it.
currently in the water vapor form,
They,
the water particles decide
leave.
to fly around. If it loses enough energy, what do? They stop doing
They
it.
bunch up.
Now, what do you call that whenever it turns from gas to liquid?
You got 1 minute left.
Salt.
Yep. Man, everyone's saying such easy. Now, what happens to the amount of kinetic energy that the water vapor particles have when it goes away? What happens to the water vapor particles when the kinetic energy goes away? The energy,
Freeze even more, no, even more.
Okay, you can take a seat. Here are the answers. Let's talk about them. Shout out the answer if you got it. Warm water has high kinetic energy, good. The particles with sufficient kinetic energy fly free of the bunched particles in the liquid water. This phase change, which goes from liquid to gas, is called evaporation. Those particles are now in the air as, what do we call that? Water vapor, right? Still water, it's just in the air. Water vapor particles strike the cold cup, or cold ice cup. Energy transfers from the particles to that cold cup. As energy transfers from the water vapor particles, the kinetic energy of those particles decreases. Right? If you've got energy that's transferring away, then the amount of kinetic energy must be lower. The particles stop
Flying.
Good. I thought that one might be kind of tricky. Stop flying, and instead they bunch up other water particles to form liquid water. This phase change is called
Condensation.
good, going from gas to a liquid. Salt added to ice in the cup makes it colder. We saw that in a couple experiments. So the condensed liquid water particles transfer even more energy to the colder ice. Why, by the way, why, when you cool that down, why does even more energy come over? Just because it's colder? Yeah.
Because there needs to be an equilibrium.
Yeah, energy's gonna continue to transfer until there's an equilibrium. The kinetic energy of the water particles on the outside of the cup decreases. Last paragraph, when the water loses enough kinetic energy, particles can't move over and around other particles, so they are
Stuck.
Alright, I had locked, but yeah, same thing, they're locked, they're stuck in place. Liquid water changes into,
Solid ice.
yeah, I would've just put ice, but gave you two blank trickiness, solid ice. Well, there's not really not solid ice, right, or we call it water, but yeah, solid ice. This phase is called, phase change is called freezing, when you're going from liquid to solid. Good? Alright. Let's do a overall review for your, getting you prepared for your test, which you will take Friday, because we got Spanish tomorrow.